G'day guys, Hector back again. Just want to do a quick video on removing Dshot capacitor. I'm not sure if this will be helpful at all, or if it's at all relevant even more anymore. But yeah, so basically, I just wanted to go over how I found the Dshot capacitor and sort of relate that to the information found here. So the first thing is telling you, to find the firmware name. Obviously, jumping over into BLHeli, you'll find your name up here when you connect, and also when you flash, it'll tell you the name of the firmware file that's about to flash, and just cancel out. It may help to write that down in the notepad. Once you've got that written down, you can head over to the repository and check out. So my particular file is CH20, so obviously maybe not. That's what we're after. Okay. So yeah. Okay. So yeah, once we're in here, we just find that. Just find that. It's easy. But yeah, make it easy. Just Control F and type that in. You'll find it's EQ0. And in fact, there's been a nice little table compiled for us. So basically, they're saying that most of them are on P05, and these particular two known firmwares currently, though there are possibilities for other configurations, so keep that in mind, are on P0, so port 0. That's over here for me, and for everyone else that's over here. Predominantly what's going to be used, and that may change, but in any case, you've got this nice little picture to guide you there. Now, quick explanation: if you can read the top, BB2 will be written like in the same style as 20 pin QFN, but it's saying find that on that chip. That's sometimes these traces, they're hard to see. You can't get a multimeter in there all the time. Like in my case, I tried to probe the pin that I already knew what pin it was, but I just wanted to make sure that the capacitor directly related to that pin. But I had an ESC right next to my particular pin. In this case, my pin was over here, and I had like an ESC somewhere around here, and when I try and probe that, it was touching ground, and I couldn't actually probe it properly, so I couldn't get in there and get it on an angle. I don't know if I was it wasn't working for me. So in any case, I had to rely on a little bit of a different method to find that. I couldn't just probe the pin directly with the multimeter. So I'll switch over to the video I recorded. I think it was like last week sometime. I've been meaning to make this video for a while. That's why I say I'm not sure if this is still relevant. But if you've got some older, like as in last week, ESCs, how fast this stuff sort of moves, you might need to remove this filtering cap. Now, I will just stop here and talk a little bit more about why you need to remove the filtering cap. So you may find Dshot 150 works, and maybe even 300 works, but then when you try and go for the faster updates, like 600, you may find that it doesn't work on the bench at all. It coughs and splutters is the best explanation for the motors, or there's nothing. It might not seem like it's playing up on the bench, but then you go and fly and there's desyncing, then obviously the cap needs to be removed. But I've been talking to a few people about this, and the general idea is that the capacitor should be removed anyway. The idea of the digital protocol is that it's going to introduce a delay, that capacitor being there. So when it goes to do the error checking, the cycle redundancy test at the end of each sort of spew out of packets, it tries to make sure it's validating these things, and if that capacitor's there, it's slowing things down. You're going to get errors in that, and that's why that capacitor needs to be removed.
We'll hook right in. So here I have a BLHS ESC, and the filtering cap is still on here somewhere. So I believe it's Dshot. I'll correct that if that's wrong. I did an excellent post on RC groups on how to find where your filtering cap is based on the CPU and what hex file you use to load. So I'll cover that at the end of this, just sort of as a confirmation to what I find here today. But so I've got a multimeter. Let's see if I can get that next to it. So I've got a multimeter on continuity, nice and simple. So this should be fairly basic for people, but yeah, over on one end. Oh. So basically we just want to probe around until we find till we find a beep, so till we get continuity. So get this right down as far as I can for you guys. Hopefully this is all in view. So I've found continuity here. What's going on here? Okay, so we get continuity here at this resistor. So this is a part of a filtering network. So, and over on the other side we get 400 ohms roughly. So so from here to there, so a resistor, we're not going to get the beep on the other side of the resistor, but we know that that is connected. And then, I mean, take a little look around. We've got a few caps here, here, and here. It's going to be one of these things. So it's not that. It's not that. Oh, what's that? 400. So we can take our probe onto the other side of this resistor and probe here. Hey. So there we go. Nice and quick. That's the capacitor that needs removing for Dshot to function correctly. Jeez, I hope that's all in view. Nice and fast. Yeah, pretty easy actually. I might just show you how I'm going to remove that myself. Obviously this is going to be different for you at home. You're going to have to either just get like a Stanley blade and just sort of pop it off. Like, do I want to do it like that? I probably don't, but that's how people at home are probably going to have to do it, is either pop it off or get a really fine tip iron. Obviously for this particular ESC they won't have to. I've done that, and I believe the company is now removing that capacitor, which is great, so people at home won't have to do this. But for older capacitors, older ESCs that have caps on the line, you will have to remove it, and that's how you find it. Yeah, so I will quickly just show you how I remove it. Bit of flux. Can never have too much. And I'm just going to come in here, grab it. Go. There it is. Baby. Yeah, and there it is removed. Laughing. After I've done that, because I did just cover this board in flux, I might just give it a bit of a clean up. And the other side. But yeah, job done. So I might we'll switch over to screen view and go over Dshot's post and on how to confirm that. But yeah, that's That's the easy way, is to grab yourself out a multimeter on continuity and just start tracing until you find it and rip it off the board. Too easy.